Hi everyone, this is Victoria Danger and this is for my MECU Mac 140 Lab 4 class. And we have in this case, we were trying to use the analogWrite to change the intensity of the light bulbs. The light bulbs are connected to the current limiting resistor that is in turn connected to the pin with the tilde sign. That is 3, 5, 6, 9, 10, 11. And this time around we're connected to the pin number 9. The other side, the shorter leg of the LEDs, is connected to the ground of the Arduino right here. We have our program. Over here, and we want the LEDs to go off, turn on in a low intensity, and then continue to get brighter and brighter, and then go back off when we've reached like the fullest brightness that we've gotten. Just gonna restart this and turn off the light so we see it. I'm gonna press the reset button of the Arduino. There we go. See clearly from this view. Slow, bright, brighter, brighter, slow, brighter, slow, bright, brighter, and go off. So in this case, we're trying to use the potentiometer to control the motor. So here we connect the potentiometer to the 5 volts power from the Arduino, connects to the potentiometer, and goes back to the ground where the wiper connects to the motor and just goes back to the ground. I'm just gonna do it right now. As I turn the knob of the potentiometer, to start. And back off. I'll turn it. Hello. In this case, we are trying to connect the pot meter, the flyback diode, the transistor, and the motor. And again, we want to use the pot meter to control the motor. We have the ground and the 5 volts here being connected to two power rail sides of the breadboard because we need 9-volt battery and we don't have one, so we're just going to use the 5 volts from the Arduino. And we have the pot meter. The wiper of the pot meter is connected to the analog AO right here, and the other two sides of the pot meter is connected to the positive and negative side of the breadboard rail. And this in turn is connected to the positive and negative side of the Arduino, the ground and the 5 volts. For the transistor, the first one, the gate, is connected to this pin right here, pin number 9, the one with the tilde sign, because we are dealing with the pulse rate modulation. And the other side of the source of the transistor right here is connected to both the flyback diode and one leg of the motor. The others, because the flyback diode and the motor, they're connected in parallel. So we have this wire. This white wire is connected to the column, and then we have this orange wire connected to this other side for the flyback diode, the anode side of the flyback diode, and this yellow wire connects to one side of the motor. The other side of the motor connects back to the positive rail right here, and we see that the cathode side of the flyback diode is also connected to that. The drain of the transistor, this blue wire is connected to the ground. And here we go, here's the circuit. Now we're just gonna connect everything back together, and we're gonna check it on the serial monitor. Here's the code. We're trying to read the pot value and change the range. We're mapping it out, changing the range from 1023 to 255, and then we want to analog write that new value, that new range, to the transistor that controls the model. Here is your monitor. As I turn the knob of the pot meter, see how it increases and decreases, and model increases and decreases. We can slowly control the speed of the model. Stop, stop, increase. Hi, so in this case, we included a push button in this circuit. We have the push button is connected to his own digital pin, and that is pin 12 right here. It's connected to pin 12, and the positive and negative side is connected to the positive and negative rail of the breadboard that is connected to the ground and to the 5 volts of the Arduino. The push button is connected to a pull-up resistor that is also connected to the positive side of the breadboard, and the other side is connected to the push button and to the pin. We have our transistor and the pot meter connected in the same way as the other circuit that we had, and the flyback diode and the model right here. In this case, we want the model to turn on when the push button is pressed, and when the pot value is greater than 500 before we map out the values to 255 to control the model. Check the serial monitor. We see now that the value coming from the pot is greater than 500, like we wanted it to be. But it's not, the model is not going to turn on because we have this AND function right here, and only if both of them are true before the if statement is true. So we have the pot value is greater than 500, and we push the push button. I'm gonna press it right now. Now if I take my hands off this push button, the model stops. Because like I said earlier, they both need to work for the model to come on.